Alright, welcome back guys. In this video we're going to introduce radical expressions and perhaps talk about radical function a little bit, but mainly just kind of do a bunch of examples. How do we evaluate radical expressions that just mainly numbers and expressions like this here. So let's get to it. Before we get to it, let's just go ahead and we're going to go ahead and recall something we already learned. And that is when we square a number. So if we take 5 and we square that, we get 25, right? Or if we take -5 and we square that, we get 25. So both of these numbers, the square of these two numbers will be equal to 25. So if the question asks what numbers square to get 9, well, that's that question there asking what number x squared to get 9, right? So when we solve equation like this here, we know that the answer we're looking for is both positive and -3. Or what number squared to get 16? Well, we know that two numbers squared to get 16 are positive 4 and -4. But when we go backwards and we ask to find out a particular number which squared to get 9 or 16 here, when we ask this here, when we ask to say, okay, what number squared to get 9, we're looking for the positive number that squared to get 9. So this is called the principal square root. Okay, anytime you type something like this in the calculator will understand that this is referring to the positive root. So this is called, so this is equal to 3. So this is called the just the principal square root. Principal square root. Okay, so just the notation itself indicates that we're looking for the positive square root one, not the negative one where you square it to get 9. Unless we solve an equation. If we solve an equation like this here, yes, we're solving for all possible number of x. But if we ask to do this here or this, we're looking for just the positive one, not the negative one. Another thing we're gonna come across is imaginary numbers. We can't find answers to certain radical expression in a real number system, so we extend it to the complex, which includes number I. So you know, if the question asks what numbers or what number squared to get -4 is something that we can't find in the real number system. So if we can try 2 squared, well, that's going to be positive 4. Some of us might say, okay, what if I want to try negative itself, -2 squared? Well, that's going to give us positive 4. So there's no such number. So there is no such real number. Okay, so we have to, you know, the answer is going to be an imaginary number, which is coming up in the end of these chapters. Okay. All right, so let's do some example here, guys. So evaluate these radicals. So remember, this is referring to the positive root only, right? This is just positive root only. So principal positive root, principal square root. So square root of 64, we're asking for what number square, what is the positive number squared to get 64? That number is 8, right? So we say because 8 itself square is 64, right? All right. Next, let's see. What number square to give us 16 over 25, and that number is going to be a fraction. It's going to be 4 over 5 because 4 over 5 square or time itself is going to be 16 over 25, right? Over here, D, what number square to give us 0.0049? So we know it's going to be in the form of 7, because 7 squared is 49, but in this case it's decimal, so we can try 0.7, which 0.7 works. 0.7 times 0.7 is 0.49, maybe 0.07. 0.07 works, so the answer is 0.07, because when we square that, we get 0.049, right? So we say because, right, if we square this, we get 0.0049. Let's look at cube root. Okay, so cube root, again, we're looking for this question you're asking what number cube, okay, what number cube to get 27, right? So that number is 3 because 3 times 3 times 3 is 27. Okay. With cube root of a negative radican, where we have negative under the radical, this asking for what number cube such that give us negative 27. That's going to give us a minus 3, because minus 3 cube is negative 3 times negative 3 times negative 3. That's negative 27. So the answer is negative 3. Over here, as I mentioned before, what number squared to give us negative 4? There's no such thing at this moment. So we're going to say this is not a real number. Okay. We soon learn how to simplify this when we learn about complex numbers. The square root function. So let's talk about square root function just a little bit. Again, suppose we don't know what the graph looks like. I'm just going to go ahead and do an XY table plot to see what the graph may look like. All right. So let's start with negative 1. Well, can we take the square of negative 1? The answer is undefined, not at the moment. So that's no. How about 0? Can we take the square of 0? What square to get 0? Well, that's going to be 0 itself. So there's our first point. We can go to 1. Square of 1 is going to give us 1. So 1 comma 1, right? What about 2? What is the square of 2? Well, we have to use the calculator to approximate it because it's not a whole number. All right, square of 2, I'm going to guess 1.414 or something like that. Okay. We probably don't want to go square root of 3 because square root of 3 is not a perfect square number, so perhaps go to 4. Square root of 4 is 2. So let's say 2, 3, 4, and then 2 right there. All right. Next perfect square number is 9. So the square of 9 is 3, 4, 5, 6, 7, 8, 9, and then 3. All right. So we can try to connect these points and make a graph here. It's going to gradually increase very slow, but it's still increasing. It's not a straight line. It's an increasing function, but it's just very low steep of increasing. Okay. Domain is going to be all the x number go from 0 to infinity. Range, the range is the set of output. The set of output is go from 0 again to positive infinity. Notice the domain of this radical function can't be negative. It has to be 0 or greater. Next up, the expression of square root of a squared. Right. Typically, when we look at this here, we say, all right, what's the square root of a squared? The answer is going to be a. I'm just going to go ahead and cancel out that out. So I'm going to get a. Is it really a? Or is it something else? Okay, let's find out. Let's play around by plugging some numbers into the square root of a squared here. So if a is 4, the square root of 4 squared, so I can say, okay, I can say that becomes square of 16, so that's 4. Okay, so in this case here, if a is 4, positive 4, the square root of a squared is going to be the same as the a value. Let's try something else. If a is negative 4, the square root of a squared now becomes square root of negative 4 squared. And we have to simplify the square inside first, so that still gives us positive 16. And then that's going to give it 4. So notice that if a is negative, we still get a positive answer, right? So going back to this here, is the square of a squared just a or something else? If we say a, it's going to be false for the negative case, right? So we want that to be turn out to be always a positive answer. So we want that to be absolute value of a. Okay, square root of a squared is going to be always absolute value of a. That will determine the answer is going to be positive. So we won't have a case where the answer is going to be negative, because if you square a negative number, you're still going to get positive output. Okay. Let's try some of this expression here. It said, assume that the variable can be represented any real number, meaning this x here can be positive, negative, a as well. So we may have to use this result here. Okay. All right. So square root of negative 6 quantity squared, using the result, we're going to get the absolute value of negative 6. So the answer is 6. Now, if we don't believe me, we can simplify this the old-fashioned way. So, okay, well, square root of the negative 6 squared, we can square the negative 6, that becomes 36, and then now it becomes 6, right? So much faster if we use the result. if we let this here be our a inside, right? So that's the square root of a squared there. So this is just become the absolute value of whatever a is. If a is x plus 2, then the absolute value of that is going to be that, okay? So that's going to be the answer for this here. This is not in the quantity square yet, so what we can do is we can factor this. This turns out this is going to be a perfect square trinomial, so the square root of that is just absolute value of x minus 4. In this case here, if we want to use this result, square root of a squared equal to a, what we can do here is we can try to rewrite this as something square, a to the white power squared. We can say that would be a to the 4th power, because if you square that's times by 2, so that becomes the absolute value of a to the 4, but a to the 4 is always positive, so we don't need the absolute value anymore, but we can just drop it, okay? Over here, square root of t to the 6, we can say, all right, well, I'm going to go ahead and make this t raised to some power to the 2nd power. So what number goes there to make it to the 6th power? That becomes 3, right? So the square root of t to the 3rd square, that becomes absolute value t to the 3rd. And then that's the answer, because t to the 3rd can be negative, so we want to keep the absolute value around that. Later on, when we learn how to change rational fraction to radical form, these problems can be done really easy. Let me just give you a quick review here. So a to the 8th square root of that, square root, we can turn that to the 1/2 power, and then now we can use the probability of exponent times 1/2 to 8, that becomes a to the 4th. So that's in the next couple lessons there. Okay. There's some more exercise for us to try here. Let's look at odd index. Okay, I want to look at odd index. Actually, let's look at x to the 3rd, the cube root of x function. So cube root functions. So what would this graph look like? That makes it different from the square root. Let's find out here. So for this graph here, it turns out that we can use any value of x. Okay, so if we use x equal to 0, we're going to get 0. If we use x equal to 1, we're going to get 1. If we use x equal to, I think the next one is going to be 8 for a perfect cube. So 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be 2. And then we can go negative direction as well. If we use x equal to negative 1, the cube root of negative 1 is going to be negative 1. So right there. And then the next perfect cube is going to be negative 8. 4, 5, 6, 7, 8. And then negative 2. So here's the graph of the cube root of x. Okay. So notice that the domain and the range is all infinite. So there's no restriction there. Okay. So that's the difference between square root and square root function versus cube root. And there's a general pattern as well. It's going to be the same thing for even index radical function versus odd index radical function. So we can pick up that later on there. Let's see here. There's a rule that I want to mention here. This is actually a definition. So this is saying that if we evaluate a radical term that is in this form where the index matches the power, okay, it depends what that power is. If the powers is even, or the index and power is even, then we get the absolute value of a as the answer. If the index and the power is odd, we're going to get a, because we can evaluate odd radical with negative underneath, or you can have negative radical with odd powers. Okay, so let me give you an example here. Something like this, right? So we can have negative in the radical there. So we can say, all right, well, if I want to use the result there, I can just rewrite this as negative 2 to the 5th power, right? So that's gonna be a negative 2, right? Because negative 2 times itself 5 times is gonna be negative 32. So where we versus this one here, okay, if we rewrite this as 3 to the 4th, right? So if if n is even, we want that to become the absolute value of 3, but in this case, or a already positive, so we just need to write 3 there. Okay, so this is the rule that helped simplify, you know, anything in this form here. Okay. I'm gonna let you guys try some homework samples and come back with questions, so I'm gonna go ahead and end the video here.